BitRobot, building the world's open robotics lab. Artificial intelligence is rapidly moving beyond screens and servers. The next frontier isn't just thinking machines, it's machines that can perceive, move, learn, and interact with the physical world. This is exactly where BitRobot comes in. BitRobot isn't just another closed research lab, and it's not a single-purpose robotics project. It's building something far more ambitious, the world's open robotics laboratory, powered by real-world data, decentralized coordination, and community-driven innovation. What is BitRobot? BitRobot is a decentralized research network focused on robotics and embodied intelligence, AI systems that learn by interacting directly with the real world. At its core, BitRobot connects robot owners and operators, AI researchers and model builders, and data contributors and infrastructure providers, all into one shared ecosystem. Here, real-world robotic data is collected, verified, and used to train the next generation of AI models. Instead of relying only on simulations or proprietary datasets, BitRobot brings learning out of the lab and into reality. Why robotics needs a new model? Modern AI has advanced rapidly because of massive datasets, but robotics faces a unique challenge. Real-world data is expensive, fragmented, and difficult to scale. Today, most robotics research is limited to well-funded labs, constrained by access to hardware, and dependent on synthetic or simulated environments. BitRobot changes this. It enables open, distributed data collection from real robots operating in real environments, homes, streets, workplaces, and beyond. This shift is critical for building AI systems that can adapt to uncertainty, handle imperfect conditions, and operate safely outside controlled environments. Subnet architecture, how BitRobot scales. One of BitRobot's most powerful ideas is its subnet-based architecture. Each subnet focuses on a specific task or research direction, such as teleoperation data collection, robotic arm manipulation, autonomous navigation, or everyday human activity datasets. This modular design allows the network to scale horizontally while staying focused and specialized. Contributors can join the subnet that best matches their expertise, whether that's hardware, data labeling, or model development. The result? Multiple real-world robotics experiments running in parallel without central bottlenecks. Verifiable robotic work. To make decentralized robotics truly viable, BitRobot introduces a key concept: verifiable robotic work, or VRW. VRW is a framework that measures real-world robotic tasks, verifies their execution and usefulness, and enables transparent reward distribution. Instead of abstract compute metrics, BitRobot values real physical world contribution, collecting sensor data, executing tasks, and validating outcomes. This creates the foundation for a sustainable, incentive-aligned robotics economy. Embodied nodes and on-chain identity. Another core idea behind BitRobot is the Embodied Node Token, or ENT. ENTs represent physical robots on-chain, giving them a verifiable digital identity, participation rights within the network, and access to tasks, rewards, and coordination. In simple terms, robots become first-class citizens of the network, not just tools hidden behind closed systems. This bridges blockchain infrastructure with physical machines, a step many talk about but few execute in a meaningful way. Community-driven, research-focused. BitRobot is built around open research and collaboration. Instead of locking innovation behind corporate walls, it promotes open datasets, shared benchmarks, and public challenges and grants. By working with research labs and open-source communities, BitRobot positions itself as infrastructure, not a gatekeeper. Because real progress in robotics comes from shared knowledge, not isolated breakthroughs. How to get involved. You don't need to be a robotics PhD or a large institution to participate. You can contribute by operating robots and collecting data, joining subnets and research challenges, supporting infrastructure or validation, or engaging in community and research discussions. As the network grows, early contributors help lay the foundation for an ecosystem that could define how real-world AI is trained in the future. BitRobot isn't promising overnight miracles or flashy demos. It's tackling one of the hardest problems in AI and robotics: how to scale real-world learning in an open, decentralized, and verifiable way. Because if artificial intelligence is truly going to understand and operate in the physical world, projects like BitRobot won't just be helpful, they'll be necessary.